There are no limits to what you can accomplish except the limits you place on your own thinking. Hi, and Hari Om children. Today we'll learn about trapezium, its properties, and how to find its area. But before that, let us start the session with prayer.
ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावतीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरि ओं श्रीगुरुभ्यो नमः हरि ओम्.
Here is a quick recall on the properties of a quadrilateral. Parallelogram. Opposite sides are equal and parallel. Opposite angles are equal. Rectangle. Opposite sides are equal and parallel. All angles are right angles. Square. Opposite sides are parallel. All sides are equal. All angles are right angles. Rhombus. Opposite sides are parallel. All sides are equal. Opposite angles are equal. Diagonals bisect each other at right angles. Learning objectives. We'll learn to find perimeter and area of simple and compound composite shapes, practice solving problems involving area and perimeter, review percentages, fractions and decimals. The keywords are perimeter, area, parallelogram, trapezium and perpendicular. Today we will learn about trapezoid, whose property is one pair of opposite side is parallel.
Television screen, an envelope, or a canvas are all examples of quadrilateral. Quadrilateral is one word, but you can see that this part is colored red and this part is colored blue. Quadri basically means four and lateral means sides. If you observe, all these things have four sides. This is an example of a quadrilateral. To name the quadrilateral, we give names to these 4 points. We call them A, B, C and D. These things that we just named are called vertices, and a quadrilateral will always have 4 vertices. Each point is called the vertex, and as we've already seen, a quadrilateral has 4 sides, and the sides are called AB, BC, CD and DA. So remember, every quadrilateral has 4 sides and 4 vertices. There's another important property of quadrilaterals. Consider this table. The surface of this table is flat. It's a plane surface. If I draw a quadrilateral on a table, it will look something like this. If you look at the quadrilateral closely, you can see that all the vertices and sides of the quadrilateral lie on one plane. So a quadrilateral has 4 sides, 4 vertices and is a closed figure lying on one plane. Observe that a vertex is formed when 2 sides meet at a point. And what is formed between those sides is called an angle. This is an angle. A quadrilateral is also defined by its angles. It has 4 angles. Apart from the one we marked, this one and this one. These are the 4 angles formed in a quadrilateral. But how do we name the angles? How can we name this green angle? Well, we can call it angle A. We just named the angle based on the vertex at which it is formed. But a better way to name it is to call it angle DAB, or you can also call it angle BAD. In these 2 cases, we named it based on the sides. Similarly, this angle can be called angle ABC. This one can be called angle BCD and this one angle CDA. And here's the last basic concept you need to know. In this quadrilateral, vertices A and C are opposite to each other, and vertices B and D are opposite to each other. The lines joining the opposite vertices are called the diagonals of the quadrilateral. So these 2 lines are called the diagonals. In this figure, we can say that AC and BD are the diagonals. What are its practical applications? When you watch this video on a 17-inch laptop, what do you think is 17 inches? It's the length of the diagonal. Even when you watch your favorite TV series on a 51-inch TV, it's the diagonal that is 51 inches. So remember, a quadrilateral is a closed figure on one plane which has 4 sides, 4 vertices and 4 angles.
In this figure, we have a quadrilateral ABCD, and AB is parallel to CD. We write it as AB is parallel to CD. And AD and BC are non-parallel sides. This pair of sides, AD and BC, is non-parallel. AD and BC, these are non-parallel sides. Okay, so if in a quadrilateral one pair of opposite sides are parallel and another pair of opposite sides are non-parallel, that quadrilateral is a trapezium. It's a quadrilateral because it has 4 sides. It's trapezium because it has only one pair of opposite sides and another pair of it has one pair of parallel opposite sides and another pair is non-parallel. That makes it trapezium. Okay? In this figure A, tell me whether this is a trapezium or not. Yes, this is a trapezium because this pair of opposite sides is parallel. This is a parallel pair. But if you look at this pair, these two opposite sides are not parallel to each other. Therefore, this is a trapezium. In this figure, again, you have a quadrilateral because it has 4 sides. And this pair of opposite sides is parallel. But this pair of opposite sides is not parallel. That makes it a trapezium. Tell about this one. In this figure, you have this pair of opposite sides parallel, but it is not a quadrilateral. Okay, so it is not quadrilateral because it has 5 sides. 1 side, 2 side, 3 side, 4 side, and 5th side.
With the help of Mikado sticks, we learn the condition under which a parallelogram is called a rectangle, rhombus and square. Friends, what is the use of understanding all different shapes or doing any kind of mathematical operation when and where it helps us? Friends, playing with these things actually sharpen our mind and also improve the basic knowledge which helps us understanding complicated things easily in future. As we apply logic in our own way on different subjects or topics, it sharpens our brain and we start thinking more logically and beautifully. So let's, while watching the session, think, question and stay curious. Now, on throwing these Mikado sticks, we see that they got arranged in some random shapes which look like a quadrilateral but not a parallelogram. And the reason for them not being a parallelogram is that although one pair of opposite side is parallel, they are not equal in length, which restricts other pair of opposite sides from being parallel. Friends, do not get confused between parallel sides and equal sides, okay? In geometry, a quadrilateral whose only one pair of opposite side is parallel is known as trapezium. Some call it as trapezoid as well. These non-parallel sides may be equal, like in our first diagram, or may not be equal, like in other 2 diagrams. Basically, there are only two types of trapezium. When these sides are equal, we call them isosceles trapezium. When they are not, they are simply called trapezium, or we can say scalene trapezium. Here are some real-life examples of trapezium. Since it is a bit different shape than that of a parallelogram, so even its properties will also differ. Like, opposite angles will not be equal, and diagonals may be equal as in the first case, that is in isosceles trapezium, or may not be equal like in any other trapezium. In isosceles trapezium, adjacent angles made by non-parallel sides are equal. In any other trapezium, they are not. So this was all about trapezium family. Till now, we have learned about two families of quadrilaterals. If anyone asks you to recognize a shape belonging to these families, I hope you will be able to. Now, there is only one family left, the kite family. We've all seen a kite flying in the sky. In a kite, there are two main sticks, which helps in the kite flying. Friends, try to make the shape of a kite along with me with these Mikado stick and write whatever you observe. I've made 3 kites and all of them are a bit different from each other. See my first kite. All its sides are of equal length. Can we call it a rhombus, which we have learned in our previous session? If all the sides are equal, they have to be parallel, so it becomes a rhombus, right? It could have been a square also, like my second kite, as it makes 90 degrees of angle at the corners. Simply, if we rotate or flip a rhombus or square, it looks like the shape of a kite only, right? My third kite is a very special one. We haven't seen such quadrilateral till now. It's both the pair of adjacent sides are equal. This is one of the criteria for a quadrilateral to be a kite. There is one more property which is only found in kite, is that we can see its diagonals are perpendicular to each other. Precisely speaking, it's one of the diagonals is a perpendicular bisector of other. Now you must be thinking that the square and rhombus belong to the family of parallelogram because both their pairs of opposite sides are parallel. Yes, you are right. In a rhombus or square, since all the sides are equal, so no doubt even adjacent sides will be equal, as well as their diagonals are perpendicular to each other. Therefore, they belong to both the families because they satisfy all the tradition, or you can say condition, followed by respective families. So friends, this was all about the types of quadrilaterals. Any other shapes which do not belong to these 3 families are simply called quadrilateral only. Broadly, we can say that a parallelogram, trapezium and kite are the family name or surname, and the figures which come under these families have their different names. Rhombus and square are in a relation with 2 families, parallelogram and kite. All these families live in a town quadrilateral. This is it for now. Let's meet in the next session where we'll deal with areas of quadrilateral and some more properties on angles, sides, etc. For that, stay tuned to Let's Tute. If you have
which is also known as a trapezium in different parts of the world. A trapezoid is a quadrilateral with one pair of parallel sides, as shown by these little arrowheads. These are all examples of trapezoids. When I first thought about finding the area of one as a student, I was confused. How can we possibly work out the area of one of these things? They can be so different. What can we do with them? You won't be surprised to know there's a trick to it. I'm going to show you the way to understand it and then how to do it really fast. We're given a length for each parallel side and the height. What if I do this to get us started on the area? Now we have two triangles. We know how to find the area of a triangle. I'll call this one A. It has a base of 7 and a height of 4. And this is B. It has a base of 5 and the same height of 4. Let's work out the area of triangle A. Base times height over 2. 7 times 4 is 28, and divide that by 2 gives me 14 centimetres squared. And for triangle B, we have 5 times 4. That's 20, and half of that is an area of 10 centimetres squared. And you guessed it, we can just add the area of these two triangles to get the area of the trapezoid, and that is 24 centimetres squared. That's pretty neat. It gives us a clear strategy. But it's kind of a clunky job, don't you think? Doing two triangles and then adding them together. There's a formula we can use that lets us work in a more elegant way. It's also much quicker. I called these triangles A and B for a very good reason. The formula is base A plus base B, you do that part first, multiplied by the height and divided by 2. This formula lets us find the area of both those triangles that we made inside the trapezoid in one calculation. Nice! Let's do the same trapezoid again using the formula this time so you can see it in action. We already know the area, of course. So here's the formula for the area of a trapezoid. Base A is 7 plus base B is 5 times the height, which is 4, divided by 2. We do the math inside the brackets first. So 7 plus 5, that's 12, times the height of 4 over 2. 12 times 4 is 48, and we divide that by 2. Half of 48 is 24. The area is 24 centimetres squared. This calculation was much more streamlined. Isn't it cool? It's so much more efficient. Think of it as two triangles combined into one shape, the trapezoid. Use the formula A plus B times the height over 2. Take down some notes and do the practice. Build the math muscle. If you can work out the area of this triangle using the formula, multiplying base by height and then dividing by 2 to get the area, then you can move over and solve the area of trapezoids too using this formula. As we saw, it's like finding the area of two triangles that make up one trapezoid at one shot. We add the two parallel sides and multiply by the height, then divide by 2, and there's the area. You can do this. Have fun and build your math muscle.
We're going to look at how to find the area of a trapezium. So here we've got a trapezium, and a trapezium is a quadrilateral with one pair of parallel sides, and I have labelled some of the key measurements that are going to help us find the area, and they are A and B, the two parallel sides, and H, which is the height of the trapezium, which is also the distance between the two parallel sides. And the area of a trapezium is given by the formula a half bracket A plus B close brackets times by the height. In other words, you add together the lengths of the two parallel sides, you half that, and then times by the height, and that gives you the area of a trapezium. This formula is very important to learn, okay, so I'd recommend you learn this off by heart. Okay, let's have a look at some examples. So here we've got a trapezium, and just to help us remember, here's the formula, okay, and let's label the sides. So A and B are the two parallel sides, A and B, and the height is the distance between them, which is 4. So A is 5, B is 7, and H is 4. So using the formula, the area equals a half. The two parallel sides added together, the lengths of them added together, so that's going to be 5 plus 7, and then we're going to times that by h, the distance between them, so that's 4. Okay, so using BODMAS, we're going to work out the 5 plus 7 first of all. So 5 plus 7 is 12, and then still timesing that by 4, and still we're going to half it. And now what we're going to do is, now we could half the 12 and times by 4, or we could do the 12 times the 4 and then half it. Both of them will give you the same answer. Just in this case, I'm going to half the 12, so half of 12 is 6, times by 4 is equal to 24. So the area of this trapezium is 24 centimeters squared. Okay, next example. Okay, this time we've got a trapezium that has got two right angles. So you'll see that the A and the B, the two parallel sides, are the 9 and the 10. The H this time, it would be the distance between them, which is this side here, okay? Because if it's two right angles, the length of the side will also be the height of the trapezium as well. Okay, so we're just going to put those into the formula. So the area equals a half of the two parallel sides added together. So A is 9 and B is 10. And we're going to times that by the height between them, the height of the trapezium, which is 8. Again, we're going to do 9 plus 10, which is 19, and then we're going to times that by 8 still and half it. Now again, we could half the 19 and times by 8, or we could do the 19 times 8 and then half it. I'm going to half it first of all, which is 9.5, and then times by 8, which will give me 76 centimeters squared. And that's the area of that trapezium. And our last example. Now this example is just slightly different because I have rotated the trapezium 90 degrees. So as you can see, it's on its side. If you want to look at it the normal way around, you can turn the page. If it's on a test paper, you can turn the test paper around to look like, the way I've had my last two examples, or you could just turn your head. But again, I'm just going to label the sides. A and B are the two parallel sides, and H is the distance between them, or the height of the trapezium. So the distance between the two parallel sides is 2. So the area equals a half of A plus B, so that's 2.5 plus 3.3. And then we're going to times that by the distance between them, or the height of it, which is 2. So that's going to be a half of 2.5 plus 3.3 is 5.8. Then we're going to times that by 2. Again, we can do 5.8 times 2 and then half it, or half of the 5.8, which is 2.9, and times by 2, which is equal to 5.8 millimeters squared. And that's it. And that's the area of that trapezium, 5.8 millimeters squared. And again, make sure you're careful with the units.
Hi, so we have one more example. Let's first read the statement. Statement says, the length of parallel sides of an isosceles trapezium are 6 centimeters and 14 centimeter. The length of each non-parallel line is 5 centimeter. Find the area of the trapezium, right? So what we have? We have one isosceles trapezium. Isosceles trapezium is a trapezium where the length of two non-parallel sides is same. Suppose this is the trapezium. Then what they are saying? They are saying it is an isosceles trapezium where the length of each non-parallel side is 5 centimeters, right? So they are saying this is 5 centimeter and this is also 5 centimeter. And what they are saying about the other lengths? Among other lengths, one is 6 centimeter. So I am labeling smaller one as 6 centimeters and the longer one as 14 centimeters. Right? Now we have to find the area of the trapezium. And area of trapezium is equal to 1 by 2 height of the trapezium multiplied by the sum of the lengths of two parallel lines. So if I call L1 as one parallel line and L2 as another parallel line, the area of the trapezium will be 1 by 2 height multiplied by L1 plus L2, right? We have L1 as 6 centimeters, L2 we have as 14 centimeter, but what about height? Height we don't know, right? So we have to find it. So what is the height? Height is the minimum distance between the parallel sides. This will be height. If I draw a perpendicular from this point to the line of 14 centimeter length. That means this is 90 degree, right? So this will be the height. Similarly, this will also be the height. So this will also be 90 degree, right? And what can we say about these two angles? This angle and this angle. If we have two parallel lines and one transversal, the sum of two interior angles on the one side of the transversal is 180 degrees, right? So what will be this? This will be 180 minus 90, that is 90 degree. And this will also be 90 degrees, right? So what we have now? We have actually divided that trapezium into a rectangle. This is a rectangle and two triangles. And what is special with these two triangles? These are right angle triangles. Since this is 90 degree, this will be 180 minus 90, 90. And this will also be 90 degree. And these two triangles are actually special. And how they are special? They have this hypotenuse, same. Both of them are 5 centimeters each. And since this is a rectangle, this side of the rectangle will be equal to this side of the rectangle, right? And since this is a right angle triangle, this side, the base, we call it as base, this will be equal to this. Why? Because if we calculate the length of the base in this triangle, this will be 5 square minus height square. This will be equal to base square, right? Similarly, if we write for this triangle, in this case also base is equal to 5 square minus height square. And what is height? Height is actually this side of the rectangle, and which is same in both the case, right? So how much will be the base? See, this much part of this parallel line actually belongs to this rectangle. So if this is 6 centimeter, this much part will also be 6 centimeters. And since both these sides are equal, we actually can find the length of the base, and it will be 14 minus 6 divided by 2. Remove this much length of the parallel side because it belongs to the rectangle, and then distribute the remaining side equally among these two triangles. So it will be 14 minus 6 by 2, which is 8 by 2, and this will be equal to 4 centimeters, right? So the length of the base will be 4 centimeter over here and 4 centimeter over here. And now if I put base equal to 4 over here, what we get? From here we can get, if we take 4 square to this side and height to this side, we will get 5 square minus 4 square is equal to height square. 5 square is 25. 4 square is 16. This is 9. And what is this? This is the square of height, right? So what will be height? Height will be square root of 9, that is 3. Yes, we have found the height. We have the length of the parallel sides. Now we can easily find the area of this trapezium. And the area of the trapezium will be, what is the area? Area is 1 by 2. Height, which we have recently found as 3 centimeters, multiplied by the length of the parallel side. So what is the first? First one is 6 and second one is 14, right? And this will be equal to 1 by 2 multiplied by 3 multiplied by 6 plus 14 is 20, right? And now if we solve it further, 2 ones are 2, 2 tens are 20. So now if you multiply 3 by 10, 3 tens are 30 centimeter square. So this is the area of the trapezium. Right? We have found the area of the trapezium when the height of the trapezium was not given to us. We have calculated the height using the Pythagoras theorem, and then we substituted that height to the formula of the area of the trapezium, and then we calculated the area of the trapezium.
Here is a quick recap on the properties of trapezium.
What is a trapezium? A trapezium is a four-sided figure. It is a type of quadrilateral. One pair of sides are parallel. In this trapezium, the side AB is parallel to DC. The sum of angle pairs between parallel lines is 180 degrees. In this trapezium, the sum of angles DAB and ADC is 180 degrees. Similarly, the sum of angles ABC and BCD is also 180 degrees.
Learning outcomes of trapezoid. Upon completion of this lesson, students will be able to derive the formula for the area of a trapezoid by combining the formulas for the areas of a triangle and rectangle using the distributive property. Calculate the area of a trapezoid using the correct units of measurement.
पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेव अवशिष्यते ॐ शान्ति शान्ति शान्तिः हरि ओम श्री गुरुभ्यो नमः हरि ओम.
Let's do some eye exercises.
Sit down on the ground comfortably. Without moving your head and neck, look upwards and then downwards. Keep your neck and back straight. Now look at the sides alternating with the left and right. Do not move your neck while looking sideways. Now look to your left, then look upwards. Move your eyes right and then look down. Look upwards, to your right, and then down. Now look upwards, then to your left and down. Now alternatively, look to your left once after looking upwards, before looking down, and then look to your right the next time after looking up. Close your eyes and rest for some time. Sit comfortably and bring your hands straight forward at shoulder height and raise your thumbs. Look at your thumbs. Slowly spread apart your hands. Look at your left and right thumbs alternatively while spreading your hands apart. Bring your hands